So we finished off indices on Friday, and I know a few people emailed me over the weekend with kind of issues or questions relating to some of the bits we did on Friday, because I know some of them were a bit tough. So I answered all of those, and you should all have got your emails this morning. If there's anything else, please do let me know. Any of those equations, I think I did most of them in the book. But there might be some in the revision exercise if anybody wants to try them, like try an assortment of them, and if you have any issues, get back to me. Okay? So today we're moving on to chapter 18 in book 2, which is trigonometry. I'm just going to do the first part, which is around Pythagoras' theorem. So this thing here, this whole top bit here, is snipped out of the Formula and Tables book. And if you can use this properly, you've no need to learn off any. I'm not sure. I think you should have done this before. Should have done this kind of at the end of first year in connection with geometry, but I'm not sure if you did. So let's have a look at this, right? So in the Formula and Tables book, I think this is on page 18, we have a right angled triangle. Okay, so as I just said, we're going to do Pythagoras' theorem. Pythagoras' theorem will only work on a right angled triangle, okay? It only works on a right angled triangle, and it will only give you sides. Okay, so if you're doing a if you're trying to find an angle, Pythagoras won't help, okay? Pythagoras will only find a side for you. Okay, so this bit here, literally for today, we're going to ignore. Okay, that bit through the centre there. Pythagoras' theorem is this thing here at the bottom. Okay, now let's relate it to the diagram above. So this little square here in the corner represents a right angle. The side opposite the right angle is known as the hypotenuse. Okay, so the hypotenuse is opposites the 90-degree angle. And another way you can pick out the hypotenuse is that it's the longest side in the triangle. Okay, so C is the hypotenuse. Good? Now, here is a marked angle A, okay? The side opposite the marked angle is called the opposite. Okay, so when it's opposite the marked angle. Okay, and then the third one, where is it? Okay, basically the one I haven't named, which is B, is known as the adjacent. Okay, and you get the adjacent by a process of elimination. Okay, you get the hypotenuse first, then you get the opposite, then the adjacent is kind of the one left out. Okay, and according to Pythagoras, you do C squared, which is the hypotenuse squared, is equal to A squared, which is the opposite squared, plus B squared, which is the adjacent squared. Okay, so that's Pythagoras. So let's try. So use Pythagoras' theorem to find the value of x in this diagram. Okay, so let's have a look. Here's the right angle over here. So the side opposite, which is x, is the hypotenuse, HYP. And if I link that back up to my diagram, I'm going to call that C. Yeah? Now, I told you that the next thing I should get is the opposite. And the way you get the opposite is by finding the marked angle. Now, hopefully you can see here that neither of those two angles are marked. Okay? So if that happens, there's no way of deciphering or differentiating between the opposite and the adjacent. So you just pick. Okay, now we'll have a look at it in a minute and I'll try and explain to you why you can just pick. So I'm going to call this the opposite, which according to the diagram up above is A. And this one down here, I'm going to call then the adjacent, which is B. So Pythagoras' theorem, you can see it just here, is C squared equals A squared plus B squared. So C is x, so we'll make it x squared. A is 5, so we make that 5 squared, and B is 12, so we make that 12 squared. Then x squared equals 5 squared is 25 plus 144. So x squared is 169. Now, I don't know if you remember this, but the way you get rid of a square is with a square root. But you have to do it on both sides so that it is balanced. So x is 13. So now I figured out that the hypotenuse x is 13. The reason that it doesn't matter which one is the opposite and the adjacent is because these two are the opposite and the adjacent here in the square. So if I picked wrong, instead of having 25 plus 144, I'd have 144 plus 25. And with addition, that doesn't matter. It doesn't matter whether it's commutative. So if you do 25 plus 144, you get 169. And if you do 144 plus 25, you get 169. Okay? So it should work either way. I hope that's okay. We'll keep going. We'll try a different one. So I have a ladder. The ladder is 5 meters long. So here's the ladder along here. It's leaning against a vertical wall. The foot of the ladder is 3 meters from the foot of the wall. How far up does the ladder go? Okay, so what we have here is a triangle like this. This is your right angle. This is x, this is 5, and this is 3. Okay, so we'll start. It's right angled, and the thing that I'm looking for, which is the x over here, is a side. So it's Pythagoras, okay? So the side opposite the right angle is the hypotenuse, which, according to the table book, is given the letter C. Again, it doesn't matter which one is, what did I do for opposite? Blue. It doesn't matter which one is which, so I'm going to call this the opposites, which according to the table book is A, and that makes the 3 the adjacent, which is B. Okay, so we go C squared equals A squared plus B squared. C squared, now this time we know C, so it's 5 squared. A we don't know, A is x, so x squared plus B is 3 squared. So 25 for 5 squared, x squared is x squared, and this is 9. Okay, now we're going to need a bit of algebra. We're trying to isolate this here, which means I'm going to need to move the 9. Okay, at the moment it's a plus 9, so I move it using the inverse of that, which is minus 9, and that will take it out. But if I minus 9 on the right hand side, I'm going to have to minus 9 on the left hand side. So I'm minus 9 over here. So 25 minus 9 is 16 equals x squared, and these 9's are gone. And then I want to get rid of my square, so I do that with a square root and a square root. So I get x equals 4. Now I've been given units on this one, so I should acknowledge that and don't just say 4, say 4 meters. So how far up the wall does the ladder reach? It reaches up 4 meters. Alright, so that's Pythagoras, okay? It's important that you take down these notes. This is literally screenshot out of the formula and tables book, and it's more so actually when we get to do this thing that I've crossed out. It's going to be really important that on the day of your exam you can take this little triangle with a pencil on your clean copy of your formula and tables book. You can put in this C is the hypotenuse, A is the opposite, and B is the adjacent. Okay, there's a huge amount of knowledge in just being able to do that. Okay, and that's how you'll start all these questions. That's how I started this one. I highlighted my hypotenuse and I called it C. Hopefully you understand the idea that if there's no marked angle, it doesn't matter which one you call the opposite and which one you call the adjacent. Because of the setup of Pythagoras' theorem, all you're doing is squaring them and adding them. So it doesn't matter which one goes first. If I had decided that 5 was my adjacent, then I would have put the 5 in here, but it wouldn't have mattered because I would just have had 144 plus 25, which is still 169, and I would have got the same answer. The easiest versions of these questions are when C is the thing you don't know, okay? Down here, we knew the hypotenuse. it was 5. It was the opposite that we didn't know. And when that's the case, it requires a little bit of algebra to rearrange the equation. Yeah, so we're going to move on then on Wednesday to the trigonometric ratios, which is the stuff I've crossed out there. Okay, so I'll come back to that, uncross it out and explain it. But for now, I just want you to concentrate on Pythagoras' theorem. So make sure you've all those notes taken down. Pause this as much as you need. It might be a nice idea, I think I said it to you, to have like, not headphones, but earphones, something small and compact that you can wrap up and put in your bag. So that you can listen to this video in class and there's not, Jesus, imagine, 30 of my voice all at different times. Nobody needs to hear that. And at least then, like, you can pause it, take your notes, play it again, pause it, whatever. So anyway, in terms of Pythagoras' theorem, that's about as hard as it gets. It's nice and straightforward when C is the unknown. Tiny bit of not the most complicated algebra in the world when you know C, and it's either the opposite or the adjacent that you don't know. Okay, but the algebra doesn't get any harder than what I did there. Okay, so I have a few questions for homework. Yeah, there they are there. With varying unknowns. So give them a try. And if you're finished and there's still a bit of time left in class, go to question 7 or chapter 7 to the revision exercise and try a few more indices equations. Okay, and then if you have any issues, you can let me know. Okay, so we'll move on to the ratios then on Wednesday.